Hello all, welcome to Narayana IAS Academy. This is Prashant. Today we will start with number system part 4, in which primarily we discuss two concepts, that is finding unit digit and counting number of zeros. So these are two important topics from which questions do come in the exam. So before starting that, yesterday I have given one homework question for you. So let's solve it. See, this is the homework question. Yesterday I have given it to you. So how many of you have solved it? The question reads, find the least multiple of 23 which when divided by 18, 21, 24 leaves remainder 7, 10, 13 respectively. Yesterday we have solved a similar question. So in this the question is least multiple of 23, and also they have given three divisors, so that is 18, 21 and 24. I have already told you, you have to first find the LCM of these three numbers. So that is 18, 21 and 24. So find the LCM. 3 6 are, 3 7 are, 3 8. Next if you put 2, 2 3 are, 2 4 are. Right. Next 3 2 are 6, 6 3 are 18, 18 4 are 72, 72 into 7. So that is nothing but 490 and 14, that is 504. Right. The LCM of 18, 21 and 24 you found out 504. Next I have told you the process. Write all the divisors and what are the reminders. So if you are dividing that number with 18, you are getting a remainder of 7. If you are dividing with 21, you are getting 10. Similarly, if you are dividing with 24, you are getting 13. And in these kind of problems, I have told you, take the remainder out of divisor. So 18 minus 7, 11, 21 minus 10, 11, 24 minus 13, 11. And also I told you, in these kind of LCM based sums, every single time you will get same difference. So this is the 11. Now what you have to do, they are asking the least multiple of 23, which is when divided by these numbers and leaving these remainders. So you have to take 504, take any multiple of 504 and minus this difference. It should be divisible by 23. Now you have to substitute values for these k. If you put k as 6, you will get 504 into 6. So that is 3024 minus 11 by 23. So this is nothing but 3013 by 23. And this is perfectly divisible by 23. So your answer will be 3013. Understood? Similar questions yesterday we have done. In that question, they have given only single remainder. When they give you multiple reminders, take the divisors and reminders, take the difference. You will always get the same difference in each case. Now they are asking the least multiple of 23. So you can take 504 into some k minus this difference. That should be perfectly divisible by 23. Substitute values k0, k1, k2, k3. If you put k as 6, you will get 3013, which is perfectly divisible by 23. So the answer is option A. So this was yesterday's homework question. Next subtopic that we are going to discuss is cyclicity or unit digit. So this is also very one important topic from which questions do come in the exam. So the questions will be like, find the unit digit of particular product, or find the unit digit of some 289 to the power 99, something like that. So questions will come. So we will discuss the concept first. So what is unit digit? We all know what is unit digit. It is the first digit of a number from right side, right? Simple one. It is the first digit of a number from the right side. For example, if you take a number 3, 2, 4, 8, 9, what is the unit digit? From the right side, the first digit. So 9 is your unit digit. If you take an example 1, 2, 4, 7, 8, 1, 4, 1, 2, 4, 8, 7. So what is the unit digit? From the right side, the first digit is your unit digit. Okay. Now, from this subtopic, mainly two kinds of questions come in the exam. The first kind of questions, like they will give you one multiplication. For example, 1, 2, 3 into 3, 4, 5 into 2, 6, 1 into 7, 4, 8. What is the unit digit of this product? So the question will be like, these kind of questions are very simple. You have to take all the unit digits and multiply. You will get the final unit digit. Either you can go from the left or you can go from the right. So if you multiply 3 5s are 15, so the unit digit is 5, and 5 1s are 5, and 5 8s are 40. So what is your unit digit? 0. Right? You can do the multiplication from the right side also, no problem. If you take 8 1s are 8, 8 5s are 40, 0, 0 3s are 0. So even if you take unit digits from the right side, or even if you take unit digits from the left side, you will get same unit digit. So what is the process for solving these kind of questions? Take all the unit digits of the individual numbers, multiply them, every single time take their unit digits. You will get the ultimate unit digit. So these are the first kind of questions from this subtopic. Second kind of questions are finding unit digits of powers. For example, there is a number like 289 to the power 324. They will ask you, what is the unit digit of this number? So these are the tricky questions. So these are finding unit digit of powers. For example, 289 to the power 324. What is the unit digit of this number? So how can we solve these kind of questions? Now there are two important rules for solving these kind of questions. The first one is, so these are basically base to the power, that is nothing but if you take that 289 to the power 324, in this is called the base, this is called power. So to find the unit digit of these kind of numbers, there are two important rules. The first rule is, if the unit digit of the base is 0, 1, 5, 6, so any of these digits are the unit digit of the base. What is unit digit of the base? This is the base. The unit digit of the base is, for example, in this base the unit digit is 9. Now what is the rule? If the unit digit of the base is 0, 1, 5, 6, let it contain any power. Any power. So the power can be anything, like 120, 900, anything. Whether it is odd number, even number, anything, then the unit digit will be same. For example, let's take, there is a number called 121 to the power 98973. Now apply this first rule. What is the unit digit of the base? That is 1. Sorry, 121 to the power. What is the unit digit of the base? 1. What is the rule saying? If the unit digit of the base is 1, let it contain any power, the unit digit will be 1. Why? Because if you take 1 to the power 1, 1 square 1, 1 cube 1, so irrespective of the power, it will give you 1 as your unit digit. Similarly, if there is a number called 686 to the power 989, apply the same rule. if the unit digit of the base is 6, here also the unit digit of the base is 6, let it contain any power, the unit digit you will get in this particular product is 6 only. Similarly, if you see 6 to the power 1 is 6, 6 square is 36, 6 cube is 216, like that. So whatever power you take for 6, you will get 6 as your unit digit. Similarly for 5 also, even if you take 5, 25, 3, 5 to the power 9, 1, 2, 3, 4. Apply the same rule. What is the unit digit of your base? That is 5. Let it contain any power. You will get the unit digit of the number as 5. Understood? Similarly, apply 5 to the power 1 is 5, 5 square is 25, 5 cube is 125 and so on. So for any power, 5 to the power contains the unit digit as 5. So this applies to 0, 1, 5, 6. But there is one exception to this any power. If the power is 0, you will get always 1. That everyone is aware of. For example, anything 589 to the power 0 is nothing but 1. So the rule is a to the power 0, 1. This any power, there is an exception, that is if you have power 0, you will get 1. So otherwise this rule applies to 0, 1, 5, 6, any power, you will get the same unit digit. Okay, this is the first rule. Next. So for finding unit digit of base to the power kind of questions, there is second rule, that is if the unit digit of the base is z, for example z, take z as the unit digit of the base. The z can be 2, 3, 4, 7, 8, 9. So z can be any of these values 2, 3, 4, 5, 2, 3, 4, 7, 8, 9. Now to find the unit digit of that number, always take the power by 4. So there will be some power 989. Take the power, divide the power by 4 with 4. So divide the power with 4. If you get a remainder of 1, your unit digit will be z to the power 1. Try to understand the rule. We will apply it using examples. Also we will solve questions. If the remainder you are getting 2, that means you are dividing the power with 4. After that you are getting a remainder of 2. Then your unit digit will be z square. If the remainder is 3, you will get a unit digit of z cube. If remainder is 0, you are getting a unit digit of z to the power 4. Why 0? Because when you are dividing with 4, the remainder can't be more than 4. So the remainder is 0, then the unit digit is set to the power 4. Let's take an example. For example, unit digit of the base is 3, like 123 to the power 89. What is the unit digit of this particular number? First, what is the unit digit of the base? That is 3. Now you have to apply this second rule. Take the power, divide it with 4, 89 divided by 4, 4 2s are 8 and 9, 4 2s are 8, you are getting remainder of 1. Now what is the rule? If you are getting a remainder of 1, your unit digit is z to the power 1. What is z? Nothing but 3. So your unit digit is 3 to the power 1, that is 3. Understood? Let's take another example like 1838 to the power 18. So there is a number 1838 to the power 18. First you have to take the unit digit of this base. So this is the base, this is the 1838 to the power 18. So this is the base, this is the power. What is the unit digit of the base? That is nothing but 8. So z is 8. Then which rule you have to apply? The second rule. So what the second rule says, first always divide the power with 4. What is the power? 18. Divide it with 4. 4 4 is 16. 2 is your remainder. Now what the rule says, if the remainder is 2, your unit digit is z square. So what is your z square unit digit? Z is nothing but 8. 8 square is 64. So 4 is your unit digit. Similarly, even if it is 9, for example 199 to the power 898. So always consider the unit digit of base. If it is 9, you have to apply the second rule. Divide 898 with 4. Take the remainder. If you are getting the remainder of 1, your unit digit is z to the power 1 is 2 z square. If you are getting a remainder of 3, z cube. If it is 0, then z to the power 4. So this is how we find the unit digit of these cases. Now let's solve a question based on these two rules. Try to solve this one. So for finding unit digit, there are two kinds of questions. The first one is direct multiplication kind of questions. In that you have to multiply all the unit digits either from the left side, either from the right side, or any order you want. So with that you will find the unit digit. And there are second kind of questions, they are finding the unit digit of powers. So that is nothing but base to the power format. For that there are again two rules. The first one is 0, 1, 5, 6. For these kind of things the unit digit is always same even if it is any power. Next one is this. Next one is this 2, 3, 4, 7, 8, 9. For these, if the base unit digit is these numbers, always take the power, divide it with 4. If the remainder is 1, your unit digit is z to the power 1. If it is 2, z square. If it is 3, z cube. If the remainder is 0, z to the power 4. So there are only these three rules. The first kind of problem, second kind of problem, there are two rules. You have to apply this very simple concept, easy questions. So try to solve this one. The question reads, the digit in the unit place of the product 81, 82, 83 and so on up till 89. So what is the unit digit? Very simple one. Within 10 seconds you should solve this question. Okay, let's see. What is the product given? 81, 82, 83, 84, 89. So if you take out 81, 82, 83, 84, 85, 86, 87, 89. Now as we discussed, take all the unit digits and multiply, but before that you can observe there is 4 and 5 or also 2 and 5. If you multiply with 2 and 5 you will get 0 as unit digit. If you multiply 4 with 5, 4 5 is a 20, 0. When there is 1 0 in the multiplication, ultimately you will get 0 as the unit digit. So the unit digit is 0. So the answer option A. So directly by seeing that you can tell, because in between there must be 85. So 2 into 5 unit digit is 0. If you multiply anything with 0 you will get 0 as the unit digit. Let's see the next question. So this is that second kind of question, second type of questions. The unit digit in the expansion of 2137 to the power 754. What is the unit digit? This is also very simple one. You just have to apply the rules. So what is the given number? 2137 to the power 754. We have discussed for base to the power. These kind of questions, if the base unit digit is 0, 1, 5, 6, let it contain any power, you will get same unit digit. Okay. Now what is the second rule? If the base unit digit is 2, 3, 4, 7, 8, 9, then what is your process? Take the power by 4 and according to the remainder, for remainder 1, z to the power 1, 2, z square, 3, z cube, 0, z to the power 4. So now apply this. What is the base unit digit? That is 7. Which rule you have to apply? Second rule. So what the second rule says? Take the 2137 to the power 754. Take the power, divide it with 4. 754. 4 ones are 4, 3 5, 4 8s are 32, 3 4 and 4 8s are 32. Remainder is 2. If the remainder is 2, what is the unit digit? Z square. So UD is 7 square, 49. So unit digit is 9. Option D. Understood? Very simple. First you have to take the base unit digit, then decide which rule you have to use. Here you have to use the second rule. Take the power, divide it with 4. You are getting a remainder of 2. Unit digit is z square. 7 square 49. Unit digit is 9. Let's see the next question. So what is the unit digit in 264 to the power 102, 264 to the power 103? Very simple question. Just figure out which rule to apply. Apply the rule. You will get the answer. Okay, let's solve this one. 264 to the power 102, 264 to the power 102 plus 264 to the power 103. Which rule to apply? What is the base unit digit? That is 4. You have to apply that second rule. What is that second rule? Take the power and divide with 103. So in this case, 102 divided by 4, 425 is 100. You are getting a remainder of 2. So here also take the power, divide it with 4, 425 is 100. You are getting a remainder of 3. Now in this case, what is the unit digit? Remainder is 2, so z square. Z is nothing but unit digit 4 square, so that is 16. What is the unit digit in this case? Z cube, that is nothing but 4 cube, 64. So what is the unit digit here? 6. What is the unit digit here? 4. There is addition in between. 6 plus 4, 10. The unit digit is 0. So the option A is your answer. So very simple. You have to figure out which rule to apply. Apply that rule. You are getting answer. Next. Find answer for this question. 4 to the power 61, 4 to the power 62, 4 to the power 63, 4 to the power 64. This sum is divisible by which of the following numbers? Even without the unit digit concept, you can solve this. With that also you can solve it. These kind of questions we should never miss. Very easy questions, low hanging fruits. Okay, try to find, let's try. What is given? 4 to the power 61 plus 4 to the power 62, 4 to the power 63 plus 4 to the power 64. Try to find the unit digit of this number. So how can you find? When the base unit digit is 4, you have to apply the second rule. So divide the power with 61. So divide the power 61 with 4. If you divide 61 with 4, what is the remainder? 4 15s are 60. So here you will get a remainder of 1. Here you will get a remainder of 2. Here you will get a remainder of 3. Here you will get a remainder of 4. Okay. Now what is the unit digit? 4 to the power 1. Here 4 square, 4 cube and 4 to the power 4. So this is nothing but 4 plus 16 plus 64 plus 256. If you do this, you will get 340. So that means 0 is your unit digit. And if go to the divisibility rules, whenever unit digit of a number is 0, that number is divisible by 10. So the answer is 10. Even without finding the unit digit also, you can solve this. If you take 4 to the power 60 common, you will get 4 plus 4 square, 4 cube and 4 to the power 4. This is nothing but 4 to the power 60 into this is nothing but 340. So whenever there is 0, that number is divisible by 10. Understood? So this particular number is divisible by 10. Option B is your answer. The next question. Try to solve this one. What is the unit digit of the sum of the first 111 whole numbers? Here you have to use what are whole numbers and what is the sum of the first 111 whole numbers and what is the unit digit of that particular sum. Try to solve it. Okay, let's solve this question. They are asking sum of the first 111 whole numbers. What are whole numbers? Natural numbers plus 0. So they start with 0, 1, 2, 3 and so on. So what are the first 111 whole numbers? They are 0, 1, 2, 3, 4 and so on up till 110. Understood? So there are 110 natural numbers plus 0. They are 111 whole numbers. Now there is a formula. Sum of n natural numbers. Sum of n natural numbers is equals to n into n plus 1 divided by 2. So this is the formula you have to know to solve this one. Sum of n natural numbers is n into n plus 1 divided by 2. Now what is the sum of the first 111 whole numbers? That is nothing but 1, 2, 3, 4 up till 110 plus 0. If you are adding 0, so it doesn't matter. So you have to find 1 to 110 sum of natural numbers. So what is the n value? That is 110. Find the sum. 110 into 111 by 2. This is nothing but 55 is equals to 55 into 111. Now they are asking what is the unit digit. So multiply these unit digits. 5 into 1, 5. So your unit digit will be 5. Answer option C. So here you have to know this formula. Sum of n natural numbers is n into n plus 1 divided by 2. Here they are asking 1115 111 whole numbers. That doesn't mean that means 110 natural numbers. So the sum is 110 into 110 plus 1 111 by 2. That is nothing but 55 into 111. So multiply only the unit digits because they are asking only unit digit. So 5 ones are 5. 5 is your unit digit. Next question. So this question was asked in the recent 2023 CSAT paper. What is the unit digit in the expansion of 57242 to the power 9 into 7 into 5 into 3 into 1? So this is just to confuse you. Very simple concept. You have three rules. The first one is direct multiplication, finding unit digit. Second one, base to the power. In these kind of questions, again there are two sub rules. The first one is if the base unit digit is 0, 1, 5, 6. The second sub rule is if the base unit digit is 2, 3, 4, 7, 8, 9. So apply those rules. That's it. This 9 into 7 into this is all just to confuse you. Very simple question. Solve this one. Okay, let's solve this one. What is the unit digit in the expansion of this particular number? So what is that number? 57242 to the power 9 into 7 into 5 into 3 into 1. So this is nothing but 3 into 5 is a 15, 15 sevens are 105, 105 into 9, 105 into 9, 45, 9, 945. So this is nothing but 57242 to the power 945, right? Now this is the base to the power kind of question. What is the base unit digit? 2. If the base unit digit is 2, 3, 4, 7, 8, 9, which rule you have to apply? The second rule. So what does the second rule say? Take the power, divide it with 4. So what is the power? 945. Divide it with 4. 4 2s are 8, 14, 4 3s are 12, 1 5, sorry, 4 3s are 12, that is 2 5, and 4 6 are 24, that is 1. You are getting a remainder of 1. Then what is the unit digit? Z to the power 1. What is this Z? 2. 2 to the power 1. So answer is 2. Very simple one. Option A. You just have to use those rules. What is the base unit digit? And then what is the power? Divide the power with 4. Take the remainder. If the remainder is 1, unit digit is Z to the power 1. Z is nothing but 2. 2 to the power 1 is 2. That is your answer. Let's see the next question. Find the unit digit of 11 to the power 11, 12 to the power 12, 13 to the power 13, 14 to the power 14, 15 to the power 15. What is the unit digit of the sum of these numbers? So here the combination of those two rules you should apply. For the base to the power kind of question only, but here you have to apply both the rules combinedly. Okay, let's solve this one. So what is it? 11 to the power 11, 12 to the power 12, 13 to the power 13, 14 to the power 14, 15 to the power 15. Now, what is the base unit digit? 1. What is the base unit digit? 2. Here 3. Here 4. Here 5. Now, if the base unit digit is 1, which rule you should apply? The first one. That is, any power it contain, the unit digit is same. So here the unit digit is nothing but 1. Now come to the second. If the base unit digit is 2, 3, 4, 7, 8, 9, you have to take the power, that is 12. Divide it with 4. 4 3s are 12, remainder is 0. Remainder is 0 means the unit digit is z to the power 4. So that means 2 to the power 4. Okay. Next, when 3, same, you have to apply the second rule, 2, 3, 4, 7, 8, 9. So that means 3, take the power 13, divide it with 4, the remainder is 1, 4 3 is 12, remainder is 1, so z to the power 1. So 3 to the power 1 is your unit digit. Similarly for 4, 2, 3, 4, 7, 8, 9, you have to apply the second rule. So that means take the power, divide it with 4, so 4 3 is 12, so 14, so remainder is 2, z square, that is nothing but 4 square is your unit digit. Now when it comes to 5, which rule you should apply? First rule, that is 0 1 3 0 1 5 6. Let it contain any power, the unit digit will be same, that is nothing but 5. So this question is a little different, where you have to apply the combination of the two rules. Now they have given addition, so you have to take sum of all these. If you take 1 plus 16 plus 3 plus 16 plus 5, so see, again you have to take sum of all the unit digits only. So 1 plus 6 7, 7 plus 3 10, so 10 means 0, 0 plus 6 6, 6 plus 5 11, 11 means the unit digit is 1. Understood? So the answer is option A. So what have we done here? For everything we have noted down the base unit digit of the given base. So 1, 2, 3, 4, 5. If it is 1, you have to apply the first rule, that is nothing but same unit digit you will get. Even for the 5 also the same rule you should apply. For 2, 3, 4, 7, 8, 9 you have to apply the second rule, that is take the power, divide it with 4, get the remainder. If the remainder is 1, z to the power 1 is the unit digit, 2 z square, 3 z cube, 0 z to the power 4. So here take the remainder, that is 4, remainder is 0, so 2 to the power 4, remainder is 1, 3 to the power 1, remainder is 2, 4 square. You have to take the sum. Again in sum you don't have to take the entire sum, just take the sum of the unit digits, because you just need the unit digit. So 1 plus 6 7, 7 3, 10, 10 means 0, 0 plus 6 plus 5 11, so that is nothing but 1 is the unit digit. Solve this question. Find the unit digit of 21 to the power 21 multiplied with 22 22, 23 to the power 23, 20 to the power 4 24, 25 to the power 25. What is the unit digit? Okay, let's solve this one. What they have given? 21 to the power 21 22 to the power 22, 23 to the power 23, 24 to the power 24, 25 to the power 25. So first thing you have to do is, what is the base unit digit in the each case? Here it is 1, here it is 2, here it is 3, 4 and 5. So for 0, 1, 5, 6, you have to apply the first rule. So for the base unit digit is 1 and 5, the unit digit will always be same. So unit digit in this case is 1, in this case is 5. What is the second rule? 2, 3, 4, 7, 8, 9. So 2, 3, 4 are here. So apply the second rule. Take the power, divide it with 4. So what is the power? 22. If you divide it with 4, 4 5s are 20, the remainder is 2. So the unit digit is z square. So that is nothing but 2 square. Okay, 2 square. In this case, 23 is the power. Multiply with 4, 3 is your remainder. So z cube, 3 cube. In this 24 is the power. So 4 6 are 24, remainder is 0. Z to the power 4, that is nothing but 4 to the power 4. So you got all the unit digits. Now here they are asking multiplication. Now there is no need to do the entire multiplication also, because this is 2 square is nothing but 4. If you multiply 4 with 5, you will get 20. So that means unit digit is 0. If you multiply any other number with 0, you will get the unit digit 0 only. So the answer is 0. That is option A. Right? Now this is your homework question. The unit digit of 1, 2, 3, 4, 5k to the power 72 is 6. Then what is the value of k? You have to solve the question. Try to come up with the answer before tomorrow's class. Now the next subtopic is counting the number of zeros. This is also one important topic from which questions do come in the examination. So counting the number of zeros. So the questions will be asked like, please find the number of zeros at the end of particular product. For example, there will be 23 into 12 into 25 into 125 into 75 into 33. So they will give you a product like this. You have to find the number of zeros at the end of this product. So how to find the number of zeros for these kind of questions? So let's understand the concept first. So in any multiplication, how do you get 0? If you multiply 2 with 5, you will get 10. So that is 0. So for one multiplication of 2 into 5, you are getting 0. That means if you want to find the number of zeros in a product, you have to find how many 2 into 5 pairs are there in that product. For example, there is a product like 2 into 5, 2 into 5. So what is the product? 2 5s are 10, 10 into 10, that is nothing but 100. So understand the pattern here. There are 2 5 pairs, there are two pairs. So this is 1 2 5 pair, this is 1 2 5 pair. When there are two pairs, you are getting two zeros at the end. Okay. If there is only one pair, you are getting 1 0. Now take another example like 2 into 5, 2 into 5 into 5. Observe here. Please tell me how many zeros you will get at the end. So there are 2 into 5 one pair, 2 into 5 two pair, but there is one extra 5. So normally we may think that okay, there can be 2 3 zeros and all, but let's take the product. 10 into 10, 100, 100 5s are 500. There are only two zeros. So here you have to understand the pairs of 2 and 5 is very important. Even if you have any extra 5, even if you have any extra 2, that doesn't matter. How many number of 2 5 pairs are there? Then it will give you those many number of zeros at the end. Even similarly, if there is 2 into 5 into 2 into 2 into 5 into 2. In this, there are 1, 2, 3, 4, 5. 1, 2, 3, 4. There are 4 2's, but there are only 2 5's. So there are 4 2's and 2 5's. But how many zeros you will get? 2 5's are 10. 2 5's are 10, 100. 100 into 4, that is nothing but 400. That is 2 zeros only. Even if you have 2 extra 2's, you are getting only 2 zeros. Why? Because there are only 2 pairs of 2 into 5, 2 into 5. Even if you have any extra 2's, even if you have any extra 5's, that doesn't matter. How many number of 2 comma 5 pairs are there? You will get those many number of zeros. So that is the concept. Let's understand it through an example. So this was the question asked in 2020 CSAT paper. How many zeros are there at the end of the following product? 1 into 5 into 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Whatever the concept that you learned, apply this, apply that concept, you will get the answer. To find the number of zeros, you have to find how many 2 comma 5 pairs are there in that particular product. So if you understand the concept, solving this is very easy. See, these kind of questions are coming in the exam. Okay, let's try to solve this one. Now the given product is 1, 5, 10, 15 and up to 60, like this they have given. You have to write this product in terms of 2 and 5. So how we can write? 1 is nothing but 1, 5 is already single 5 only. 10 can be written as 2 into 5, right? 15 can be written as 3 into 5. So you can do this prime factorization indirectly. What is 20? 5 into 4. 4 is nothing but 2 into 2. So 5 into 2 into 2. Next 25 is nothing but 5 square. So there are 2 5's, 5 into 5. Next 30. 30 is nothing but 5 6. 6 is nothing but 2 into 3. So 5 into 2 into 3. What is the next one? 35. That is nothing but 5 into 7. 7 cannot be written as 2, 5 or nothing. So 5 sevens are 8. 8 is nothing but 5 8. 8 is 2 cube. So 5 into 2 into 2 into 2. Right? Similarly, what is 45? 5 nines are, and 9 can be written as 3 into 3. Next 50. 5 tens are. So 5 into 10 is nothing but 2 into 5. Next, what is 55? 5 into 11. 11 is a prime number, so cannot be further divided. What is 60? 10 into 6. 10 is nothing but 2 into 5. 6 is nothing but 2 into 3. Now find how many number of 5's are there, number of 2's are there. How many number of 5's? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 5's are there. Now how many number of 2's? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. You can see how many number of 5s are there? 14 5s are there, 10 2s are there. Now how many number of 2 into 5 pairs? So there will be only 10. So this 14 is nothing but 10 plus 4. That means there are extra 5 5s, extra 4 5s, but that doesn't matter. As we discussed in our concept, these extra 4 5s doesn't matter. So only there are 10 2 into 5 pairs are there in this product. So that means 10 number of zeros. Got it? So what are the number of zeros in this product? That is A. Option A, 10. Understood? So for finding number of zeros, you have to extract the number of 2, 5 pairs. If you are getting 10 pairs, you are having 10 zeros. Simple. Using the similar concept, try to solve this question. Similar concept. Find the number of zeros in the product 56 to the power 99 multiplied with 125 to the power 89. Apply the same concept. Try to find the number of 2 and 5 pairs. Then you will get number of zeros. Okay, let's solve this one. What is the given product? 56 to the power 99, 125 to the power 89. So 56 to the power 99 multiplied with 125, 89. So you have to do the prime factorization so that you will get all the 2 and 5 pairs. So 56 can be written as 7 8s, right? 7 into 8. 8 is nothing but 2 cube, right? So 99 into what is 125? 5 cube. So you are getting 89, right? So this is nothing but 7 into 99 into 2 to the power. What is 99 into 3? So that is nothing but 270, 27, 297. So 2 to the power 297 into 5 to the power 5 cube to the power 89. So 3 into 89. So what is 89 into 3? 240, 27, 267. So this is nothing but 5 to the power 267. So here also there are 5 to the power 267, 2 to the power 297. So there are extra 2's, but that doesn't matter. You have to take out only 5 into 2 pairs. So this is nothing but 7 to the power 99. So this can be written as 2 to the power 267 into 297 minus 260 is nothing but 30. So this is 5 into 267. So these are the number of pairs, right? So this extra 2 to the power 30 doesn't matter to us. So 2 into 5 power is 267. So how many 2 into 5 pairs are there? There are 267 pairs. Or else simply whenever you get this powers multiplication and all, 2 into 2 to the power 297, 5 to the power 267, take the smallest power, that is your answer. Take the smallest power, because that one only will give you number of 2 and 5 pairs. So 2 and 5 to the power 267. So these many 2 5 pairs are there. So the number of zeros is 267. Option A. Understood? So you just have to divide the product into prime factorization so that you can find how many number of 2 and 5 pairs are there. So if you get any multiplication like this based on powers, 2 to the power something, 5 to the power something, always take the smallest power. That is your answer. Now, this is the second model question from this subtopic, counting number of zeros. So what was the first model question? So that is, you have to divide the entire product into 2 into 5, right? So 2 into 5 pairs you can divide the product, then you can find how many number of 2 into 5 pairs are there, then that is your number of zeros. But if you see anything like this, that is nothing but 1 into 2 into 3 into 4 up to 1000. So this is a very long multiplication. You cannot do that individual 2 into 5 prime factorization. That is going to be very difficult. So these are the second model questions from this subtopic. Nothing but continuous multiplication of numbers. Continuous multiplication. So in these model questions, this is also called as this factorial, right? What is factorial? N factorial is nothing but n into n minus 1 into n minus 2 up to 1. So if you see, this is nothing but 1, 2, 3 up to 1000, 1000 factorial. So in these kind of questions, multiplying or dividing the entire product into 2 and 5 prime factorization is going to be very difficult. So how to solve? How to find the number of zeros? Take this highest number, okay? Divide it with 5. Now in this division, you have to consider only the quotient. So if you divide 1000 with 5, 5 200s are 1000, you are getting remainder 0. So this is the dividend, this is the divisor, this is the remainder, this is the quotient. Now here we need only quotient. What is the quotient? 200. Even if you are not getting 0 remainder, that is fine. You have to consider only quotient. So if you divide 1000 with 5, what is the quotient that you are getting? 200. Now take the 200 again, divide it with 5. 200 by 5. Okay. So 200 by 5 is nothing but 540 is a 200. Remainder is 0. Even if remainder is not 0, consider the quotient. What is the quotient? 40. Again take the 40 by 5. 5 eights, that is the quotient. Now you have to repeat this process until you get a number which is less than 5. Okay, then only you can stop the division when it is less than 5. So again take the 8, divide it with 5. So if you divide 8 with 5, 5 ones are 5, remainder is 3. Whatever is the remainder, we don't care about that. What is your quotient? 1. Okay. Now this 1 is less than 5. You have to stop the process till here. Now take sum of all the quotients. What is this? 200 plus 40, 240, plus 8, 248, plus 1, 249. The sum of all the quotient is 249. That is your answer. So what are the total number of zeros? 249. So if you understand, in finding the number of zeros, the earlier concept was you have to find number of 2 into 5 pairs. If they have given you any product, you can find how many number of 2 and 5 pairs are there. But for this continuous multiplication, that is nothing but this factorial based questions, finding 2 into 5 pairs is going to be very difficult. So for that, we have to use this process. Take that highest number, divide it with 5. You have to remember, divide it with 5. Take the quotient. So if you divide it with 5, you have to take the quotient even if remainder is not 0. So take the quotient 200. Take the 200 again multiply with 5, quotient 40. Again multiply with 5, quotient 8. Again multiply with 5, quotient 1. Here you are getting remainder of 3, but we should leave that remainder. Take only the quotient 1. Now 1 is less than 5, so stop the process till here. Take sum of all the quotients. So 200 plus 40, 240, 248, 249. So total number of zeros are 249. So this is how you should approach these kind of questions from this subtopic. Let's take another example. So using the same process, try to approach this one. A similar question, this is also. So the question reads, find the number of zeros at the end of the product 10 multiplied by 20, 30, 40 up to 1000. So this is not the first kind of questions in which you found 2 into 5 pairs. Here that is impossible. So try to apply the previous process. Okay, let's solve this question. The product given is 10 into 20 into 30 so on till 1000. So when there is continuous multiplication of numbers, that is nothing but factorial concept, you have to use that process. But here this is not continuous multiplication. 10 after 20 is coming, not 11, 12, 13. So 10, 20, 30. But if you take out 10 from here, from every number, this is nothing but 10 into 1. 20 is nothing but 10 into 2. 30 is nothing but 10 into 3, and so on. 1000 is nothing but 10 into 100. So take the 10 out. So there are 100 terms. 10 is there 100 times. So 10 to the power 100. So if you take that out, the product is 1, 2, 3 into 4 up till 100. Now this is nothing but continuous multiplication, factorial concept. How to find a number of zeros in this product? Take the last number, divide it with 4. What is the quotient? 25s are, sorry, you have to divide it with 5. So 20s are, take 20 by 4, right? So 4 5s are, sorry. Take 20, divide it with 5. 5 4s are. Now the number is less than 5. Stop the process till here. 20 plus 4. 24 zeros are there in this product. So in this product there are 24 zeros. Now in this term how many zeros are there? 10 to the power 100. That means 10 is being multiplied 100 times. In 110 there is 1 zero. 100 times there are 100 zeros. So in this there are 100 zeros. In this there are 24 zeros. So what are the total number of zeros? 100 plus 24. 124 zeros are there. Understood? So what is the answer? Option C. So when there is continuous multiplication of numbers, that is nothing but factorial concept, you have to use this particular process. Here there are no continuous numbers, but if you just take 10 out, you are getting the factorial. So if you take the 10 out, 10 to the power 100, then you will get 100 factorial. For that, apply this process. You are getting 24 zeros in this product, and in this there are 100 zeros. So total zeros are 100 plus 24, 124. Let's solve the next question. The number of zeros at the end of 100 factorial plus 200 factorial. Let's solve this one. What are the number of zeros at the end of 100 factorial plus 200 factorial? 100 factorial is nothing but 1 into 2 into 3 and so on 100. So this is continuous multiplication of numbers. Apply the second process, that is take the 100, divide it with 5. What is the quotient? 20. Take 20 again, 20 by 5, quotient is 4. The number is less than 5, so stop the process. So total is 20 plus 4, 24 zeros are there. So in the first product there are 24 zeros. Next, second, 200 factorial, that is nothing but 1, 2, 3 up to 200. Continuous multiplication of numbers. So take this highest number 200 divided by 5. So that is nothing but 40. Again take the 40. 40 by 5 is nothing but 8. Again take 8 divided by 5. The quotient is 1. So 40 plus 8, 48 plus 1, 49. So there are 49 zeros. There are 49 zeros in this product. Now here is the tricky part. In the first product there are 24 zeros. In the second product there are 49 zeros. Now they are asking addition of the first and second. When you are adding two products, how many number of zeros? For example, take 500. How many number of zeros are there? 2. Take 1000. How many number of zeros are there? 3. If you add these two, how many number of zeros will come? So you will get 1500. Still you are having 2 zeros only, because after these 2 zeros there will be some numbers. So which when you add it to here, you will ultimately get the smallest number only. So out of 2 and 3 you are having 2 zeros only. Similarly, take any other example to check. 880. How many number of zeros are there? 1. Take any other product. 15,000. 15,000. How many number of zeros are there? 3. So if you add it here, you are getting 15,880. Still you are having only 1 zero. So whichever is the smallest number, those many number of zeros only you are having. So in the first product there are 24 zeros. In the second product there are 49 zeros. But when you add both, you will get the smallest number only. So the answer will be 24 zeros. You should not add 24 and 49, whichever is the smallest number. If you multiply, you can multiply these two. Understood? For example, multiply 500 with 1000, you will get 500 0 0 0 1 2 3 4 5. You have to add the zeros. For multiplication we have added already. So but when you are adding it, you are getting only the smallest number. So out of 24 and 49, you will have only 24 zeros. Option B is the answer. Understood? So this is the small trickiest part. You have to understand that. So this is the last question from this. You have to apply the same concept everywhere. Find the number of zeros at the end of the product 32, 33, 34, 35 up to 75. So what are the number of zeros in this product? You can pause and solve it. Okay, let me solve this one. The given product is 32, 33, 34, 35 up to 75. And what we learned, when there is continuous numbers, that means the number should start from 1 to any particular number. That is only factorial concept. When there is factorial concept, you have to use the process. Take the highest number, divide it with 5, take the quotient up till that process and add all the quotients. Now the problem here is numbers are starting from 32 up to 75. If it is starting from 1 to 75, I can take 75 and do that process. Now what should we do here? This is also very simple. This is nothing but 1 into 2 into 3 at up to 75 minus 1 into 2 into 3 up to 31, right? So 30 to 33 up to 45 is nothing but take the total product from 1 to 75. From that, take out 1 to 31 product. You will get 30 to 75 product, right? Now this is the continuous numbers concept. How many zeros will be there from here? So what is the highest number? 75. So divide it with 5. 75 fives are, so quotient is 7 ones are, 7 fives are. Again take 15 fives are, 5 threes are. Now the number is less than 5. So total number of zeros is 15 plus 3, that is 18. Now from this, what are the total number of zeros? That is nothing but take the highest number, divide it with 5. So 5 6 remainder is 1, but that will not matter. So take again 6 divided with 5, so 1. So that is nothing but 6 plus 1 is 7 zeros. Now the total number of zeros is 18. Total number of zeros is 7. Now we have to subtract it. So 18 minus 7 is 11. What are the total number of zeros? That is 11. Okay. So when there is continuous multiplication of numbers, that is nothing but factorial, you have to apply the process. So when you do not have that factorial kind of product, convert this product into that factorial mode. So 1 into 2 into up to 75 minus 1 into 2 into up to 31. So there are two products which are in our continuous number form. So apply the same process. Here you are getting 18 zeros. Here you are getting 11 zeros. So with this, today's number system part 4 is completed. So here we discussed mainly two subtopics, that is cyclicity or unit digit, finding the unit digit, and the second subtopic that we discussed was counting number of zeros. So these are two very important topics. Several times questions were asked in the exam, and tomorrow we will start with, that is the last part for the number system, part 5, that is remainder theorem, finding the remainders. That is also very important. Several times many questions were asked. So tomorrow we will discuss that subtopic, reminders. Thank you so much.